Alright, so today we will be talking about inverse trig functions, specifically inverse trig functions. Now, what this does is it undoes the other functions. If you're not sure what that means, here's an example. If you have f of x equaling 2x, then the inverse of that will be the inverse of f of x equals x over 2. Basically, this little -1 right here, that's the inverse sign. It undid 2x and turned it into x over 2. And something that's important to know, that not all functions have inverses. Keep that in mind. Now to decide whether or not a function has an inverse or not, mathematicians way back in the day had created something called the horizontal line test. And that is basically where you take the graph of a function and you draw a horizontal line through it. And if that line touches 2 points on that function graph, then it does not have an inverse. But if the line only touches one of them, then that's the case. For example, this graph right here, this fails the horizontal line test because the line touches more than 1 point on the graph. But this is the example that I was talking about that the mathematicians came up with, where basically they covered up half the graph. That's why my hand is here, if you see the little extra, and they just focused on this. They limited the domain to be able to look at trig functions. So basically this passes because it only hits 1 point on the function, and then the function ends at the apex. And now we're going to be looking at the inverse of sine. The inverse of sine is the same thing as arcsine. Let me show you. Well, the domain of the inverse of sine is negative pi over 2 to pi over 2. This is what the graph of. Oh shoot! Hold on. I forgot to specify, but the dotted line, I believe, is sine, and the undotted line isn't. Damn, I forgot the other ones. During the presentation of the video, I'll let you know, identify which one is sine and which one is the inverse. But I believe that the solid line is the graph of sine, and that the dotted line is the graph of the inverse of sine. And also, sine equals opposite over hypotenuse, and opposite over hypotenuse is the same thing as the y value over the radius. So keep that in mind as well when you're trying to figure out these problems. Inverse of cosine. The inverse of cosine of x is the same thing as the arc cos of x. The example for that would be the inverse of cosine of the square root of 2 over 2. The way that you figure that out is that you basically map it out and graph it. You have, well, cosine is equal to adjacent over hypotenuse. So this is the adjacent value, which is right here. My fault. Right here. My fault. Right here. No. Yeah, it's right here. My fault. This is the adjacent, and the hypotenuse is right here of 2. And with this, with these values, you can also identify that it is a 45, 90 degree triangle. And the answer to this problem would be 3 pi over 4. I'm not sure why, but it is. And then the domain is limited to -1 and 1, and the range is limited to 0 and pi. Yes, and as I already said, cosine is adjacent over hypotenuse and x over radius. Alright, whatever. And then the inverse of tangent is the same thing as the inverse of tan or arctan of x. And the domain of the inverse of tan or arctan is negative infinity to infinity. And the range is negative pi over 2 to pi over 2. And an example would be the inverse of tan of the square root of 3. You graph that out, and after you plug in the values that you have, right now all you know is that you have an opposite value because you don't have an adjacent. Yeah, so you know if the opposite is the square root of 3, and then you can plug in 1 for the adjacent to give you a value to go off of, and from that you know that you have a 30, 60, 90 triangle with a hypotenuse of 2, and the answer to this problem would be pi over 3. I'm not sure how, but do you know how it's that? I mean, I know that's right, but I forget that. And then you know that tan equals opposite over adjacent, and that it equals y over x, and that's it.